Okay, welcome back. In this class, we are going to discuss about transconductance, output conductance, and figure of merit. Observe very carefully here. We know that conductance, here also conductance. Conductance is nothing but what? Reciprocal of resistance. The absolutely reciprocal of resistance. Therefore, the units may be mho, okay, or ohm inverse, or you may call the units are Siemens. This is a very important thing you have to remember. And coming back to the definition of transconductance, output conductance, and figure of merit, transconductance is defined as the ratio of change in drain source current with respect to change in gate source voltage, where the drain source voltage is constant. And similarly here, if you observe, the output conductance is defined as the ratio of change in drain source current with respect to change in drain source voltage, where the gate source voltage is constant. And coming back to the figure of merit, it is defined as the ratio of transconductance with respect to gate to channel capacitance. Now we are going to derive each and every parameter in terms of two regions, saturation and non-saturation region. Now if we look about the drain source current in active region. Now if you differentiate this drain source current with respect to gate source voltage by assuming the drain source voltage as constant, now what will happen? Observe very carefully. Now this you may call it as transconductance. Then what will happen if you observe very carefully? Now here we do not have any gate to source voltage term, therefore it becomes 0. And here if you observe that, okay, let beta keep aside, it is a constant. You are having two terms. One is what? VGS into VDS is one term, and minus VT into VDS is another term. I hope that are you clear. Now if you observe further, you do not have any VGS term, therefore it becomes 0. Then what is the remaining term for you? Beta into VGS into VDS. If you differentiate with respect to VGS, then this VGS gets equal to 1. Therefore the transconductance in active region becomes what? Beta into VDS. Now can anybody try to tell in which region? Saturation region. Okay, in saturation region, anybody from the class? Okay, what is the transconductance? Absolutely, in saturation region, transconductance is equals to beta into VGS minus VT. Why it is? Yeah, absolutely. Why? Because in saturation region, VDS is greater than or equals to VGS minus VT. Therefore, we can consider the equality condition. That's it, guys. This is about the transconductance in active region and in saturation region. Now we will see the output conductance in both the regions. Is it okay? Now we are going to derive output conductance in both the regions. Now if you observe that, if you differentiate, that means if you differentiate partially the drain source current with respect to now drain source voltage, where VGS we have to maintain as what? Constant. Absolutely. Now you can observe that here, if you observe that when you are going to differentiate with respect to VDS, now you may observe here VDS is there, therefore this becomes 1. This is the remaining term. And here you may observe that VDS square is there, therefore it becomes what? 2 VDS by 2. 2 gets cancelled, therefore what is the remaining term? Absolutely. Therefore you can tell that the output conductance GDS is equals to beta into, okay, what is the term remaining here? Absolutely, VGS minus VT, okay, minus what is the term? VDS. Is it clear? This is in active region. Now what happens in saturation region? Anybody? In saturation region, what is that? Okay, absolutely. Why? Because here the in saturation region GDS is equals to 0, guys. Why? Because you can clearly observe here, okay, since we know that in saturation region this VDS is equals to what? Absolutely, VGS minus VT. Therefore this VGS minus VT minus VGS minus VT becomes cancel, therefore it becomes what? 0. That's it, guys. This is about the output conductance in both the regions. Now we will see about the figure of merit in both the regions. Is it clear? Now we are going to derive the figure of merit in both the regions. If you observe that, we know that figure of merit is defined as the ratio of transconductance with respect to gate capacitance. Okay, therefore I have considered the transconductance in active region. We know that transconductance in active region is equals to beta into VDS, but we require in terms of gate capacitance, therefore beta is replaced with gate capacitance here, like that. Now you require GM by CG, therefore I am going to consider GM by CG. Now you can call this one as what? Figure of merit. Now you may observe that which is equals to mu by L square into VDS. Is it clear? Now you can observe, if it is NMOS you can write mu N, if it is PMOS you can write mu P. That's it guys, this is about figure of merit. In which region? Active region. Now you may observe that in saturation region, what will happen? Yeah, absolutely, omega naught is equals to mu N by L square. This VDS can be written as absolutely VGS minus VT. Is it clear? Thank you very much. This is about GM, GDS and omega naught. If you are having any queries, you may ask. Okay, thank you very much. Have a nice day.